Hey guys, this video will show an example of how you can perform a hypothesis test for a population mean using a t-distribution. This is from the Module 12 content. Right now I'm in the Module 12 folder in Blackboard, and you guys should be working on the study plan hypothesis testing for population means this week. And this video will go through an entire hypothesis test and show you how you can use the t-distribution to find p-values, and we'll perform an entire test. So right now I'm going to do an example from the Module 12 Notes Part 3 that I posted in Blackboard today. We'll do one problem in the video, and you guys should then try to do the other two on your own. In the notes here, you'll see that we're going to perform hypothesis tests similar to what we did before with proportions. The type of test will be based on the inequality symbol in the alternative hypothesis, and we have the right-tailed, left-tailed, and two-tailed tests. And the difference now is that the hypotheses will be statements about a population mean. Prior to this, the hypotheses were statements about a population proportion. And once you get your hypotheses based on the research question, you'll then identify the sample statistics. We're then going to calculate a t-score, and then we'll find the p-value and make a decision. So you guys can go through these steps in detail. What I want to focus on just real quickly is that we're going to be calculating a t-score here, which is basically a z-score of the sample mean based on the assumption that the population mean is the value from the null hypothesis. And we're going to be using a sample standard deviation, S, instead of a population standard deviation, and that's going to then require that we use a t-distribution. So let's jump right into a problem. We'll do the first problem here. So question 1 says, a survey of large U.S. cities found that the average commute time, travel time one way, is 25.4 minutes. A Chamber of Commerce executive from a large northeastern city believes that the commute time in his city is lower than the national average. So these two statements are what we're going to use to get our hypotheses. First, what is the claim? The claim is that the mean commute time in this northeastern city is lower than the national average. So let's start there. So I'm going to put this in Desmos here. So let's start with the claim. The claim is that the population mean, which is the mean commute time of the people in the city, the mean travel time one way for adults in the city, is less than the national average, which is 25.4 minutes. So this is our claim. So from this we get our hypotheses. The null is going to be that the population mean is equal to the value 25.4, and the alternative hypothesis will be that the population mean is less than 25.4, and this is consistent with the claim here. So here basically the claim that the population mean is less than 25.4 will be the alternative, and the null always has an equal sign. Because we have a less than sign, we're going to do a left-tailed test, and the type of test determines how we compute the p-value, which we'll do once we get to, of course, to that step. So we have our hypotheses. The null has an equal, the alternative has a less than. Population mean is mu, right? The Greek letter mu, but I can't put that here, so I'll just write population mean for mu. And let's now identify what we know from the sample. So we're looking for three things: sample size, sample mean, and sample standard deviation. So it says he randomly selects 24 commuters and finds the mean commute time to be 22.6 minutes with a sample standard deviation of 5.2. Notice how this is a sample standard deviation. So because we don't have the population standard deviation and we're using this sample standard deviation to approximate it, we're going to use a t-distribution. So our sample statistics are going to be 24 for sample size. So n equals 24. The sample mean, which is x bar, right, 22.6 minutes, and the sample standard deviation 5.2 minutes. And we can use these sample statistics to assess which of these hypotheses we think of course is correct. Because we have 24, a sample size of 24, the degrees of freedom is going to be 24 minus 1, which equals 23. So we're going to essentially end up using a t-distribution that has 23 degrees of freedom, right? So this is the key. We must use a t-distribution probability curve to get the p-value. So you guys can put this, if you're as you're watching the video, you can take notes on this as well. Okay, so let's now compute the t-score of the observed sample mean. So this t-score is going to be t equals 22.6 minus 25.4, right? The sample mean is 22.6. The assumed population mean is 25.4 from the null hypothesis, right? Remember, the null is that hypothesis states that the population mean equals 25.4. So mu is 25.4 here. And we're dividing this by 5.2 divided by the square root of the sample size, which is 24. So this is basically a z-score, and we can interpret it in a similar way. If a z-score is less than -2, it means that the statistic is highly unusual. Well, here we have a t-score, which is -2.64. So this is certainly a very unusual statistic. This sample mean is highly unusual from a random sample of size 24 if the population mean is truly 25.4. Well, let's now get our p-value. We're doing a left tilt test, so we can go now to the t-distribution app to get the p-value. And when you go here to the t-distribution app, go to find probability, because we're finding a p-value, which is a probability. We have 23 degrees of freedom, left tilt test, and the test statistic is -2.64. -2.64. Okay, so we're getting a p-value here of 0.73%. This left tilt area is the p-value, which is 0.73%, which is very low. That's less than 1%. So we can see that the sample mean that we have in this particular hypothesis test is very, very unlikely if the population mean is truly 25.4. So let's now wrap this up. So we have our p-value. The p-value is equal to 0.073%, 0.73%, which in decimal form would be 0.0073. Alpha is 0.05, and we can see that in the problem. All right, it says at alpha equals 5%, is the executive's belief correct? So we're going to compare the p-value to alpha, and when we do that, we can see that the p-value is less than alpha. When the p-value is less than alpha, remember our p-value here is only 0.73%, which is less than 1%. Since the p-value is less than alpha, what do we always do? We reject the null hypothesis. We support the alternative hypothesis. So our conclusion here is that we are supporting that the mean commute time of the adults in the city is less than 25.4 minutes. So we're concluding that the mean commute time of adults in the city is less than the national average. So let's write that down. So at alpha equals 0.05, we can conclude that the mean, average commute time, this is one way travel time for adults in the city, this large city, is less than the national average. Right, and that's our conclusion. So we are, again, rejecting the null hypothesis, right? We're rejecting the null. We are supporting the alternative. So therefore, we conclude that the population mean is less than 25.4. All right, guys, the key with these problems in Module 12 is you're going to be using the t-distribution now to find p-values. and you have to identify the degrees of freedom, that's just the sample size minus 1. So as you're doing your problems, please write down the information kind of in an organized manner like we do in class, and that'll help to make sense of these problems.